Welcome, and today we're going to be going through the Unit 4 test review using the review test in the workbook. You should have the workbook out while going through this. You may answer your workbook questions as we go through these problems, and I will explain how to solve each problem and what is expected in the answers. And question number 1, each and every one of these problems, A through F, will equal one of these three answers, either 43, 430, or 4,300. We're going to be solving decimal problems with powers of 10. So I'm going to show you, I'm just going to model a different kind of problem. We're going to change the numbers a little bit. And so let's try 53 times 10 to the first power. 53 times 10 to the first power is simply 53 times 1, which is 53, and add 1 0 for two reasons. You can choose whichever reason you like. Either because there's 1 0 in the number 10 or because the exponent is 1. 10 to the first power is the same thing as 10. So we're really multiplying by just 10, which means you're going to add 1 0. Now, if we were to multiply 53 times 10 to the second power, 53 times 10 to the second power is still 53 times 1, which is 53. 10 to the second power is the same thing as 10 times 10, or 100. 10 times 10 is 100. We would know to add 2 zeros to this for one of two reasons. Either because you know that 10 to the second power is 100, and 100 has 2 zeros, or you would just look at the exponent and realize that 10 to the second power means that you're going to add 2 zeros. And the final one would be 53 times 10 to the third power, which would be 53 again by multiplying the whole numbers and adding 3 zeros for one of two reasons. Either you're looking at the exponent to tell you how many zeros to add, or you know that 10 to the third power is 10 times 10 times 10, which is 1,000 and has 3 zeros. As you complete each and every one of these problems, you're going to put the letter in the correct box that has the answer. So I'll do A for you. 43 times 10 to the second power is 43 with 2 zeros, and so the letter A should go in this box. The rest of these you can do on your own. Number 2, you put $62 from your paycheck into your savings account, and you get paid every 2 weeks, or 26 times per year. Your goal is to save $1,600 this year. Will you reach your goal? It says to explain your answer using words, a model, and an equation. The first thing you're going to want to do here is to figure out if he actually can save enough money. And we have the information to do that. He's taking $62 from every paycheck, and he gets to do that 26 times. There's many ways you could solve this problem. Of course, we probably want to use multiplication. It'd be the easiest way. You could simply add $62 to itself every time he gets a paycheck for 26 times and continue to do that till you get to 26. You want to rewrite that probably standing up, and that is not the most efficient way to do this, but it could be done that way. Or you could just simply multiply 62 times 26 and see if indeed he could save enough money. So you do your 6 times 2, which is 12. 6 times 6, which is 36, plus 1 is 37. Placeholder, 2 times 2, which is 4. 2 times 6, which is 12. And add those and get 2, 11, 6, 1. So the short answer is yes, he can. We've proven that. And now you're going to need to explain how you know this is true in words. And you could do that simply by stating that after adding $62 26 times, that he would indeed save $1,612. Or you could explain your multiplication, how you multiplied. Or perhaps you did it a different way, and you could explain that way as well. You could show a model by remembering some of the ways that we learned how to do double-digit multiplication with 4 squares and 2 squares. So a simple model would be to take your 62 and break that into 60 and 2, and your 26 and break it into 20 and 6. and then fill in your model here. And this would be 40, and this would be 36 with a 0, and this would be 12. And then you could just show that, and then in your statement you could say that you added all of these squares, or you could even just show the addition of those squares, or you may even want to do the problem using a 4 square. Remember that we've used 4 squares, 2 squares where we did expanded notation for one of the numbers like 20 and 6, but the other number we didn't expand. We also had a shortcut method, which is what I used over here. And we even had another method that was very similar to the shortcut method, where you regrouped below where the answer was instead of above where the factors were. Number 3 asks you to choose a factor from each column that will result in the product having 3 zeros. You're going to need to play around with these numbers and try some things to see if they work. For example, we might take the number 2 and try to multiply it to 4/10, in which case you would get 8 and move the decimal one time, and you would see that that doesn't result in any zeros, so that's not going to be a good combination. And there's only going to be one item bubbled from each side. So you're going to bubble one item from this side over here and match it with one item from this side over here, so that when you do multiply the 2 that you bubbled, you will have a product with 3 zeros in it. And obviously 2 and 4/10 is not going to be the answer because that doesn't give you any zeros. 2 times 4 will not be the answer. Obviously it doesn't give you any zeros. 2 times 40, well, that will give you some zeros, but I'm going to allow you to go ahead and go through that and play with those factors and find a combination that will give you an answer that has 3 zeros in it. Number 4 asks you to select the product that is correct. If it is correct, there might be more than one. I won't spoil that for you, but this is mental math and easy enough to do. But bubble in each and every one that is correct. For number 5, you're going to select each item with a product that's equal to 260. Mark every one of these that is equal to 260. Go through each and every one, solve them, and in these cases here you're going to be moving decimals. That's all you're going to really need to do there. If I were to give you this problem, 37 and 4/10 times 10 to the second power, you could simply move the decimal 2 times in the right direction, and that would be right because we're multiplying by 10 to the second power. Our answer should get larger, so we're going to move the decimal this way 2 times, and that would lead you to 3740, and then your decimal, which is no longer needed because we don't have anything after it, so we could just take that off if we want. You could do it simply by moving the decimal that in the right direction, which would be right, or you could rewrite this problem as 37 and 4/10 times whatever 10 to the second power is, which is 100. And at this point, you're just going to be multiplying your whole numbers times 1, and that would lead you to 374, these numbers times 1. We ignored the zeros, and then we're going to add those back now. And then count your decimal places, and your decimal would go right here, moving over from here to here, moving one spot because of the 1 digit that is behind the decimal. And you see you get the same answer, 3,740. Well, for each of these problems over here, you need to figure out if they are equal to 260. There will be more than one, and bubble in all that apply. For number 6, we're going to write a decimal to complete this equation. So here we have an original equation with an equal sign, which means both of these sides need to be equal because there's an equal sign. So 7 times 4 hundredths is the same as 7 times 4 times what? That's what you need to enter in that box. Well, we have the 7 here and we have the 7 here, so that's already equal on both sides, but what we have here is 4 hundredths and here we have 4. In order to make 4 hundredths with this 4, you're going to have to multiply 4 times what? Enter your answer here. So I assembled a similar problem here. We're taking 5 times 4 thousandths is the same as 5 times 4 times what? So what would I put in this box so that it will equal 4 thousandths? because I need to have both sides exactly the same, so these two things need to be over here. So far I only have the 5, but I have an empty space, and if I put the right number in here, it will also equal 4 thousandths. And in order to get 4 thousandths, when you're starting with 4, then you need to multiply it by 1 thousandth. 4 times 1 thousandth is 4 thousandths. For number 7, you're going to have to settle a dispute, because Ben says the product of these two numbers should have 2 zeros, and Charlene says that it should have 3. So in the first box, you're going to tell me which student is correct, and you're also going to tell me what the answer to this is. But in box B, you need to tell me how you know. And please either describe how you did it in words or show me with a model. There's models that you could show me. You could do a 4 square or a 2 square model, or you could just show me the work, do the work itself, just line them up, 50 times 60, and show me the work. Any work that provides me with the correct answer will be good enough in this box to tell me how you knew. Number 8, you're going to need to order the products, those are answers, from least to greatest by writing each expression in a box. You might see the least to greatest in the review, but you might see that reversed on the test, so make sure you're paying very close attention to the wording here. You have them in the right order. So you're going to have to solve each of these boxes individually, and my suggestion is you put the answers above the box or below the box, but not in the boxes below them, because that's where you're going to rewrite your answers from least to greatest. You must have them all out first, and then you're going to need to compare those numbers. And some of those might be decimals, so make sure you're comparing whole numbers first. As I taught you, that when you are comparing decimals, that you should be circling the whole numbers first. Every number in front of the decimal should be circled. You should compare these two first. Read them, 21 and 21, they're equal. And then go to the first decimal place and compare those. The 1 is larger than the 0, so this is greater. Remember to do it that way, because if they're out of order, the problem will be wrong. As you know, there's several ways to write multiplication problems. We have exponents we can use. We can expand our exponents like they're doing in this problem. And this is where we're going to need to know those skills. We're going to select every single problem here that is equal to this problem. So the first thing you're going to want to do is figure out what this problem equals, or maybe that's not necessary for you. It depends. But this problem is going to be 8 times 1 times 1 times 1, which is 8. And then add your 3 zeros for the three zeros that you see there. And then you go and solve each one of these problems and put your answers next to the problem here. Don't forget to do your parentheses first here. And providing me with those answers might help you out in case you misbubble something. Most of these problems could be done in your head. We're just adding zeros. We've done this before. We're looking at the exponents of our powers of 10 to see how many zeros to add. So I know that you could solve them in your head, but please place your answers next to each problem so that I can see visually that you know how to solve each of them. Number 10, a simple word problem. Obviously, it's multiplication because that's all we're doing this unit. You can solve this by setting up a multiplication problem. No decimals there, so it should be easy. Double-digit multiplication. Use any method you want. Number 11 is a two-part question and 2 points. Jody's best score in a video game is 50 points. Mark's best is 1.5 times higher than hers. So how many points did Mark score in the video game? Again, set up your multiplication problem any way that you wish and find the answer to that question. Then part B, Virginia scores only 0.6 of a time, or 0.6 times Jody's best score. And so again, you're going to have to find out how many points Virginia scored by setting up a multiplication problem using Jody's score and what we know about Virginia's score. Problem number 12, you're going to have to remember how to do the 4 square. Showed you that earlier in an earlier question, how to model the 4 square. Again, if you're doing a 4 square, it's nice that they set it up for you. Let me create a new one here. These 2 boxes up here are for you to break your number into 2 separate numbers. You're going to break them into the value of each digit. So if we had 83 times 42, you could choose to put 83 on top or on the side. If we put it on the side, it'd be 80 plus 3. Therefore, 40 plus 2 would have to go on top. We're breaking the numbers down into the value of each digit. The value of the 8 is 80, and the value of the 3 is 3. The value of the 4 is 40, and the value of the 2 is 2. And then for each box here, we're doing 80 times 40. We're doing 80 times 2 here. We're going to solve that. We're going to do 40 times 3 here, and we're going to do 3 times 2 here. And so we solve each of these boxes, put the answers in the box, and then that's what you're going to put over here is the answer. And you can do the work somewhere else. And then add them all up to find the total number for square inches. The total is going to go here. I expect to see each box here with the answer. This box should have the answer to these two. This box should have the answer to those two. This should be these two, and this should be those two. And then you'll add them all up and put the answer here. We're going to skip number 13. Woohoo! Question 14 is 3 parts and 3 points. Each one of these, you're going to need to circle one of these numbers, one of these powers of 10 that will make these equations true. Quick example problem over here. We have 43 hundredths times one of these powers of 10 equals 43. Well, in order to get 43, you would have to move this decimal how many times? In order to get 43, this decimal has to move from this spot here to the right 2 times. Put it to the end of 43, you'll end up with 43 decimal, which is the same thing as 43. Well, how many times did I move that again? Twice. And so I'm looking for a power of 10 that would make me move that decimal twice, and that would be this one, 10 to the second power. And so that's all you need to do here is figure out how many times to move the decimal and then locate the power of 10 that would tell you to move it that many times. Number 15, you need to describe how digits shift when you multiply a number by 1/10. Well, I'll show you how they shift when you multiply a number by 100th. I'll take any number, and that's all you need to do is take any number and multiply it by 100th to show that. And then you could show that 3 times 1 is 3, and we had to move the decimal 2 times. We had to add a 0, and our final answer here is decimal 0.3 or 0 3/100ths. And so how many times did the digits shift? And we're talking about the digits shifting, not the decimal shifting. The decimal did move. When we look at our final answer here, and we compare it to our original number, which is 3, the 3 has shifted. The decimal used to be right here. And it's not there anymore. Here's where it used to be. But the decimal has shifted 2 times to the left, which means the digits have shifted 2 times to the right. They go the opposite direction as the decimal. All you need to do is describe that in words. Please proofread your answer. We are skipping number 16. Woohoo! Number 17 is pretty self-explanatory. All you're going to need to do here is solve this problem. Find the answer. When you do, it's going to be over here somewhere. Figure out where that answer is and put this letter in the appropriate box. Show all work for all problems. These are the types of problems where you're going to need to show work that cannot be done in your head. Number 18 is a word problem. We are doing it. A walking stick is 2.5 times longer than a praying mantis. If you knew how long a praying mantis was, you should be able to tell me how long a walking stick is. They tell you how long a praying mantis is right here. It's also a power of 10. There's several ways to solve this. Could be done in your head, or you may need to write it out. Number 19 is a problem we are going to do. I want you to take your time on this and maybe even replicate a problem, create a problem so you can see what happens. When you multiply by 100, each digit is shifting which direction and how many times. The how many times part I know is easy for you, but make sure you're getting the right or left part correct. Remember that the digits shift the opposite direction as the decimal. Number 20 is a multiplication problem, single digit. You'll need to do that problem and put the answer in the box provided. And the second part says explain how you know your answer is reasonable. And reasonable is one of those words where it should automatically trigger the estimate word, because if you're going to see if something's reasonable, you're generally you're going to be just estimating these numbers to see if your answer is close to that. So if you rounded this up from 7,952, you'd round it up to 8,000, and this you could stay the same because it's single digit. If you did 8,000 times 8, that answer should be close to what you ended up with when you solved the actual problem. So you're going to have to explain how you know it's reasonable by telling me how you rounded them off and what your answer was when you rounded them off and solved it in your head. It's not going to be an exact answer, but a rounded answer. But it should be close, within reasonable range of your actual answer. Number 21 says select the products that are correct, mark all that apply. There'll be 1 point for this, and you will be just solving each problem. Actually, they're already solved, but you need to solve them yourself to make sure that the answers are correct. Bubble in the ones that are correct. Number 22 is a word problem we will be solving. Again, remember to use your strategies for word problems. Circle your numbers, make it personal. Realize that we are working on a unit of multiplication, so finding the right sign shouldn't be that difficult, but play the situation out in your mind and try some things and make sure that your answer is reasonable. It makes sense to you. 23, also a word problem. Mr. Clemente is measuring 29.7 grams of potassium chloride for each of 7 lab groups in his chemistry class. How much potassium chloride did Mr. Clemente measure? Well, he did it 7 times, so he took 29.7 grams 7 times. So you can show that, show your work again on that, and drop your answer in the space provided. And the last question, 24, when you multiply these two numbers, 24 and 7/10 by 1/10, is the answer greater than or less than 24 and 7/10? So we're starting with 24 and 7/10, and they're asking that if you multiply by a fraction or a decimal, which are the same things, 1/10, this is 1/10 and could be written that way. So if you're taking 1/10 of this, would your answer be less than or greater than the original number? This could be done without doing any work, but I highly suggest that you work the problem so that you can see if the answer is less than or greater than. And once you know that, then you can work on explaining it. You will remember from fractions that if you had 10 bananas and I asked you to take 1/2 of those bananas from your table, how many would you be taking? So 1/2 of 10. You are only taking 5. And that answer is less than what you started with. And remember why? Because you started with 10 and you're only taking half of them. You're not taking the whole bunch. You're not taking all of them, just a portion of them. So it makes sense that your answer would be less because you shouldn't be taking all of them. And you can't take more than you have. That answer would be unreasonable. So use that example to help explain why your answer came out the way that it did.